In this video, I will show how to solve an initial value problem using the integrating factor approach. First of all, we have to recognize that we have a linear equation. That is, we have an equation in this form. It is derivative of a function plus some function of x times the unknown function, and all that is equal to some function of x. And once we identify our equation as linear equation, we multiply both sides of the equation by the integrating factor, which we find by evaluating this expression. And after we multiply by the integrating factor, the left-hand side becomes the derivative of the integrating factor and our unknown function y, and the right-hand side is just mu times q of x, where mu is the integrating factor. And after that, we find the antiderivative of both sides, and then divide both sides by the integrating factor to isolate our function. And since we have an initial value problem, we would have to also evaluate the constant to make sure that both conditions are satisfied. So let's get started. First, find the integrating factor. It's going to be e to the power integral of 2 dx, y2, because 2 is the coefficient of y. Integral of 2 is 2x, so our integrating factor is e to the power 2x. Multiplying everything by e to the power 2x gives us the following equation, and on the left hand side we recognize the derivative of the product of e to the 2x and y. Now we isolate e to the 2x times y by taking the antiderivative of the right hand side, and the derivative of the right hand side is just 1/2 e to the power 2x, and we add the constant of integration here. And since we have an initial value problem, let's find this constant of integration right away. So let's plug in 0 for x and 3 for y. So we have 3 equals 1/2 plus c. Therefore, c is equal to 5/2. So our solution in implicit form is equal to this expression or equation, and dividing both sides by e to the 2x gives us the function in explicit form. So this is how we solve a given initial value problem using the integrating factor approach.